Hello guys, it's Dr. AJ. So today we have example on truss. This is definitely a question in the FE exam. So let's get started. So as you can see here, we have this truss system and we have 2 kips applied and 8 kips. Each one of those members is 6 foot. This is given and they are looking for forces 1, 2, and 3 plus their orientation if it's in tension or compression. So 6 foot is the length of each one of those. First, we need to find the reactions and then we will find the forces. When it comes to the reactions, we have hinge, so it resists right to left, right, and it resists top and bottom. And we have a roller here, so we know it resists just the top and bottom. So it just regardless, really, always think about it practically rather than you memorize it. So when you have a roller, it's like you have a tire. You know the tire is gonna just move right or left, but it's not gonna go up and down, right? So you're gonna put resistance, you're gonna put reaction where there is a resistance. And the same when it comes to the hinge or sometimes called pin joint. You know it accepts rotation. But so that's why you don't see moment here, resisting for moment. But you will see there is a resistance for X movement and Y movement, which is the top and bottom. So in order to find the reactions, we need to apply the equilibrium equation, summation Fx, Fy moment. If I were you, I always put the direction and put them the positive. Like it is up to you really, but you can put it the other way. Like instead of, for example, now the summation Fx is directing to the right, this is the positive sign. I can just basically have it directed to the left and call it this is the positive. So what I'm trying to tell you here, always stick with the sign. Like if this is your positive, keep it positive for the rest of the solution. Do not change it. Like for example, the moment now it is clockwise, it is positive. So let's keep it always a clockwise positive. It will make the solution easier and it just reduces significantly the amount of confusion. So you're not going to make mistakes. So to find the reactions, really, summation Fx, we start with this one. We can find this is the easier basically just because we have only one force applied that way and it resisted by the reaction at X. So summation Fx will be 2. It's positive because it's directing that way to the right. And RAX is directing that way. By the way, you can put the directions the way you want it. Really, like I can just put RAX directing to the right instead of the left. But just I think it comes from experience that since you're applying that way load, you will be resisted that load that way. So 2 is positive based on this is directing that way, right? RAX is negative, so that's gonna give us a reaction A in X direction 2 that way. So now we will find the reaction at B. We found RAX, we will find RB. So in order to do that, so we need to find the vertical reactions, so B and A. We're going to take a moment here to find the reaction at B. So, but we need something else. We need the vertical distance because when we take the moment 2 times the elevation, that distance, which is Y, we don't know that. So, but we know this is equilateral triangle. The total angle of a triangle is 180, so that means each one of them will be 60, 60, 60. So sine of 60, it is the raise, which is y over the chord, 6. So that means y equal w sine 60, 6 times 0.866, so that's going to give us a y of 5.2. So now we know this height. So we're going to go ahead and apply summation moment at A. So 2 is basically this force times 5.2. This is the elevation. We just found that. Plus. So this is positive because we're saying if it clockwise, it is positive and it's going that way, right? Around A. So it is positive. Plus 8 times 6. Why do we put plus? Because also it is positive. This is A and this is the 8 kips and this is A. So it's going that way if you do the rotation thing. So it is positive. Minus. Why minus? Because RB, we assumed it's going upward. So it is going that way, right? It's rotating that way. What's the distance? 12. From here to here it's 6. From here to here 6. So it'll be 12. So that's going to give us an RB reaction of 4.87K upward. We're right. So, and then we will apply summation Fy equals 0 to find the last reaction Ray. So we assumed it to be as well resisting the 8 kips that going downward. You can assume it really going downward, and then if you get a negative result, that means it should be upward. So it's just an assumption. So this is very important to also stick with your assumptions, and then if you get a negative result, it means it's the other direction. So RAY is going upward, that's why it's positive. Minus 8 because it's going downward, and this is the positive sign. So plus 4.87, which is RB, and that's going to give us RAY of 3.13 kips upward. Now let's determine the forces. What we're going to do, basically, we're going to make a cut here. It's going to give us something like that. That's when you cut it, really. This is F3, what we're looking for. And then we have the force CE that go into the joint E, and we have the force F also required that's going to the joint E. We know from here to here is 6. From here to here, the vertical distance is 5.2. We just found that, really. So, and we know the reaction here at V. So if we take a moment at E, we can find the forces F3. And in this way, we basically avoiding dealing with F1 and the force in CE, since they are going to the same joint we're taking a moment about. So the positive sign, again, we assumed it clockwise. That's why you'll see F3 times the vertical distance, 5.2. It is negative because it's going counterclockwise that way, counterclockwise. And then RB, we know it's upward. So times 6, it is also negative because it's, again, it's counterclockwise. So F sub 3 minus 5.6 in tension. If it's in tension, it is minus that way. So that means since we get a minus for tension, then that means the member F3 is actually in compression. So F3 is 5.6 kips in compression. So let's go ahead and find the force 1. We can use the same sketch we used for the F with the same cut we did. So we're going to take a moment around C. We need here something else. We need the distance from RB to the center, really, of C. So cosine is basically that horizontal dimension over the chord. So the chord is 6 foot. We know that. Cosine 60, we know that. So we will get a distance of x equal to 3 foot. So F1, we assumed it in tension, times 5.2, the vertical, right? Because we're taking the moment here, minus the reaction, 4.87 times 3, which is the distance from here to here. So this is positive because it's going clockwise, minus because it's going counterclockwise, right? If I were to do the rotation of this, it will rotate that way. So to do the mathematics, we're going to get 2.8 K. So finally, let's find the force F2. So we go to the structure, really, but this time we're going to make a cut here. That way we know the reactions here, and so we know this force, we know F3, and we can find the force F2. So when you make the cut, you will get something like that. So 2 kips here, D joint is here. F2 is what we're looking for, and we have the reaction. So if you look at it for a second, you will see you can apply only one equation and call it good, which is summation Fy. You don't want to go with summation Fx because you will involve the force, this one, in F3 in your calc, and also you have to find the forces AE if you're making the cut that way, right? So you don't know, you know this one, but you don't know that one, so it makes it one more step. You need to find this before you find this, but it's a lot easier if you do just summation Fy, and because this is the only element will be involved in the equation. So F2y basically is F2 sine 60, right? This is the sine. If you take this number, it's here, it's the sine. right? So F2 y is F2 sine 60. And then we do just the summation of y equals 0. 3.13, this is the reaction, and it's positive just because it's going upward. Minus, because we assumed the intention, and that means this one is going downward. F2 sine 60, which is 0.866. That's going to give us F2 of 3.6 Gibbs in tension. So those are the forces of 1, 2.8 in tension, 3.6 in tension, F2, and F3, 5.6 in compression. So we go to the options really, and it is actually option D. But please pay attention because option C is the exact same numbers, except that the orientation is different. You can see like F2 is in compression, while the correct answer is in tension. And the same for F3 and in tension, and it should be in compression. With that, thank you very much, and we'll see you next time. If you like the video, please don't forget to like and subscribe. Thank you.